The Longman medical terminology show that the horseshoe shape of the cardiogenic area in the cross section and mid-sagittals. As you see here, and I draw for you, the heart situated in front of the future brain. We have to change the positions. Huh? This is a lateral, the cephalocaudal folding. Look at the position of the heart and that's the A pictures. Here. This is the cephalocaudals, and finally they come from the front of the future esophagus, as I draw for you. And this one is lateral folding. The two arm of the horseshoe here we have the two tubes. And finally the two tubes join together and we have a one.
Doctor, there isn't a pointer. There is no pointer.
Okay. This is the one tubes here. Before we have the two tubes, and when they join, they have a one tubes.
So they make the endocardial tube?
Cardiac.
Yes. This is a show that a mouse embryo. This is a show that the cardiac leukins. This is a heart in the mouse embryo. This is the brain of the embryo. They come into the thorax here. Before that, the heart situated in here. The pictures show the A to C, the lateral, like my pictures, show the cardiac leukins. Look at the change of the position of the cavity. Again, cardiac looking. The final, the mouse embryo, two ventricle, left and right, and two atriums. This is the outflow part of the heart. The heart, the AV canal before divisions. Okay, this is the outflow, the two atriums. As my picture, as I show you, this is a vein systems. You can see the finally left sinus hole make a coronary sinus. This is the final, this is a coronary sinus made by left horn of the sinus venous and oblique vein of left atrium. The both of them made by left horn of the sinus venous and right horn participate here. Participate in the formation of the right atriums. The septation of the atriums, you can see the septum primum up. Okay, here it is coming down, the ostrum primum. The ostrum primum is here is closed, and that one is ostrum secundum. Here we have a two septum, septum primum and septum secundum. Is it clear? Yes. How the cavity be expanded? D1. Expansion of the right and left atriums. Let's show the formation of the cushion. Do you know the cardiac cushions? It's formed by the here again, the final normal development. Here is a foramen ovals. The blue color is the septum secundum. The red color is the septum primum. If you look at it on the right side, the blue color is the septum secundum. The red color is the septum primum. Is it clear?
Yes. Doctor, can you go through the process of them like getting made, developed? The process of them getting developed.
Which was?
The septum primum and ostium primum.
I told you that first of all the septum primum, it's coming down, the age pictures. And first of all we have a temporary foramen, that means ostrum primum. As a result of a growing of inferior cardiac cushions, the foramen primum is closed and one foramen secundum or ostium secundum is closed. It remains open till to the base. And the right side of the septum primum, a blue color, septum secundum is growing down. Is it clear?
What's the other name for the ostium secundum?
Ostium secundum or secondary opening.
Secondary.
Yes, it's the Latin word. Ostium secundum is Latin. Secondary opening or secondary foramen is English.
So it's different from the second.
Septum secundum, ostium secundum.
Huh.
Septum means wall. Ostium means opening. Is it clear?
Okay.
Septum is wall-likes. But here is opening. We have a one septum secundum, one ostium secundum. Here is ostium secundum is opening. Here is the septum secundum. Is it clear? This is a show that the A1's formation of the cushions, and finally when that the most right sides. Finally, we have a right atrioventricular canal and left atrioventricular canal. It's happened when we want to make a two AV canals, right and left. This is a mouse embryo. Again, the mouse embryo show that the real mouse embryo by scanning microscopes. Exactly the same of the schematic pictures. How the chorda tendina and valve of the tricuspid and mitral are formed. By cell death, you can see that finally we have, for example, this is a mitral valve. As you know in the anatomy, each valve connected to the papillary muscles by chorda tendina. Okay, we have some abnormality you can see in the pictures. During the formation of the septums, sometimes we have some abnormality. For example, this is a normal septum formations, the A1. The B, excessive resorption of the septum primum. As a result here, we have an interarterial defect. Compare this B to A. Look at the red colors. Yes, excessive resorption. When we want to make an ostium secundum, the large ostium secundum is formed. Very large, larger than normals. For example, we have to make this small opening. Sometimes the opening be larger, like this one. Is never enclosed after the birth. As a result, we have a right to left shunt. The one absence of septum secundum. The never septum secundum is forming here. Look at the normals. Compare. Again, we have interarterial defects. And this one, it's a severe abnormality. The never septum primum and septum secundum are formed.
This
We
case,
have a common arterioles.
in this case, what will happen?
This case, usually, the most of them are died. This one. But this one and this one may be alive and need to the surgery to repair.
Directly after birth, right?
This one may be before the birth. Exactly 1 month after the birth. They alive 1 month after the birth are alive. Because the repair of this one is not happened by surgery. We have a similar. Okay. Look at the pictures now here. In my pictures. Look at the hairs. Do you remember here we need to make a one
Septum.
interventricular septum, like interarterial septum.
Septum.
Here, fortunately, we have one septum, but the septum has two parts.
Right and
One muscular part, you remember from the anatomy?
Yeah.
Muscular, and one membranous part.
yes. اسمه كان منطلق.
Interventricular septum. Okay? In anatomy, we say that interventricular septum has two parts. One muscular, one
One
membranous. The muscular part formation
Inferior.
is easy, has an easy mechanism. Is made by proliferation, like cushions. Huh? But the membranous is complicated structure. Is made by three cells. It's made, this is important for the final exam, it's made by three cells. Okay? Look at the another pictures. This one is the inferior cushion here. This is the AV canals. This is the AV canal. Right AV canal. And this one is the left. Is it clear? The blood drain to the left side from the left atriums. And here, the blood from the AV side drain to the right side of right atrium, huh? Here, as I told you that we have one muscular part. It's forming here. But look at here, the connection is not in. We have a free connection here. It's not completed. At the same time, look at here. What the name of this part? Do you remember the name of this?
Truncus.
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 Truncus
Arteries.
arteriosus. And this one? Conus
Arterios.
Coronus
arteriosus. Okay? The one third lower, you remember, made the right ventricle.
Right wing.
Okay? The conus arteriosus made the outflow. Here is the conus cordis, and here is the truncus arteriosus. Is it clear?
Yeah.
Please compare here the original pictures. You remember
Yep.
the same names. CC, it means conus cordis. TA means, okay. What should I do now here? Is it necessary to make the one septum in here or not?
Yeah.
Like arterium, like the ventricles, huh?
Yeah.
We have to separate this to right and
Left.
left by two septums again here. But what the name of these septums that separated to the right and left? No, not here. This is the interventricular. What the name of here?
This
should be interatrial.
Interpoblius.
No.
Aorta.
It's easy. Here, two septum. One of them from the right, one of them from the left. Okay? The most cells that making this septum, they come from the neural crest. This is important. The source of the cells for the separation. Is it clear? This is important. the neural crest from the brain is coming here because we don't have any cell in here. We don't have the mesodermal cells. All of the mesodermal cells take part in the formation of the heart. Huh? We need two sources of the cells. Is it clear? Which sources?
Neurons.
They come from the
Brain.
brain. Is it important? Because if this neural crest don't migrate it here, we have a cardiac abnormality. Is it clear?
Yes.
Sometimes it happens because the neural crest cells are sensitive to oxidative stress. Maybe they don't migrate it to here. The most of the cardiac abnormality is happening as a result of the damage of neural crest cells. Is it clear?
Yes.
Spatially in this area. Two septums here, one of them the right side, one of them in the left side, made by neuron. What the name of this one? These two septums?
Atrial and
No, it's easy.
Neurons.
Right.
Trancoconal. Trancoconal, right and left. Two septum developing here. Tranco, because not only they divided the truncus arteriosus, but also divided the cunus cordis. Look at me, please. I made a one septum in here. Huh? The one septum from the right, one of them in the left. Both of them joined together. Its name is right trancoconal and left. Is it clear?
Yes.
You never forget it. Right and left. Trancoconals. The right and left trancoconals separated the outflow of the right and left side and separated the pulmonary and ascending aorta. Exactly. The lower part, this is important. My best topic in here. Huh? The lower part of the trancoconal septum, right and left, plus inferior cushions. Because here we have a two septum, huh? Right and left. And here is a cushion. The lower part of the trancoconal septums, it means right and left, plus inferior cushions, participate in the formation of the
Membrane.
membranous. Is a main conclusion. Is it clear?
Yes.
What's the origin of the membranous part of interventricular septums?
Right and left.
Which part?
Or
Lower
Lower
parts.
part.
Lower part of the right
Of
and left trancoconal cushions, septums, plus inferior
part
cushions. Do you remember?
Yes.
Do you remember I told you that inferior cushion is important because not only participate in the formation AV canals, but also participate in the formation interarterial septum and interventricular. Do you remember?
Yes.
That's all. Okay, please coming back here. Here is a normal heart. You can see the muscular and membranous part. Here is abnormal. Tricuspid atresia. Here we have two terms. Stenosis and atresia. Do you know the difference? Do you know different between the stenosis?
Atresia means
Stenosis?
atresia means the narrowing of a canal or an opening.
No, the atresia it means it doesn't form. For example, if it's one foramen is closed completely, we say that atresia.
And stenosis when two things fuse, right?
It's narrowing. For example, this is a one. For example, this is a opening of ascending aorta. If it's be narrow, very narrow, small, or we say that no, stenosis. But if it's closed completely or
Atriosis.
destroyed, we say that.
Atriosis.
Do you understand me?
Yes.
Here in the B, we have a atresia. It means that the tricuspid valve, you can see here. Look at here, we have a tricuspid. It's open, it's normal. But what happening here?
It's not full.
Trees, yeah.
It's
So it's
not
closed.
full, it's completely closed. Huh?
Yes.
We say that tricuspid. What's happening? Here, do you remember in anatomy, between the arc of aorta and first arc of the left pulmonary,
Ligament.
we have one ligament, ligamentum arteriosus.
Arteriosus.
Before the birth, it's open. We say that, what the name before the birth? Ductus arteriosus. We have in the tricuspid atresia, we have an interventricular septum defect and opening ductus arteriosus. Because blood have to go to the lungs by this pathway. This interesting picture show that the formation of the truncocranial septum. You can see by red and yellow colors. The picture show that during the formation they turn around each others. If this turning doesn't happen, look at the pictures. You can see that here the three colors meet each others. The lower part of the truncocranial, the blue color is inferior cushion, or the formation of the membranous part. Here is defect in the intermembranous septums, the B pictures. Compare A and B. Is it clear?
Yeah.
This one is a tetralogy of Fallows. In the tetralogy of Fallows, we have an interventricular septal defect, a stenosis in the pulmonary artery, overburdening of aorta, and the defect of the interarterial septum, and patent ductus arteriosus. We have four signs together, and the right ventricle hypertrophy. Tetralogy of Fallows. Look at the B pictures, hypertrophy of the right ventricle, interventricular septal defect, pulmonary stenosis, patent duct
Doctor, this tetralogy of
Arteriosus.
Fallot, it's happened after development of the heart, after finishing.
It's happened during the formation of the heart,
Also,
but it's treated by the surgery, fortunately.
yeah, because we studied also in the physiology that in the adult
You
heart.
read it?
What?
You read it in the physiology?
Yeah. We studied that in this case, tetralogy of Fallot, but I wasn't know that it's happening for the embryo also.
Yes, you read it. Because the defect has embryological, it's an embryological difference. As a result, you can see that the abnormal physiology in the function of the heart.
So it's embryological.
Yes, it's embryology.
In all of the cases, it's embryological issue, right?
Yes, all of these cases are good. And this one, what do you think that? Persistence of the truncus arteriosus is interesting cases. You remember for the separation of the truncus arterius and conus cordis, we need two septum. Huh? If they never neural crest migrated here, we don't have the truncoconal septum. Huh? As a result, we have a common, like a embryo. Here we have a common cavity. Look at the pictures. Defect in the interarterial interventricular septums, and we have a common trunk that receives blood from the two ventricles at the same time. Is it clear? If you learn the normal embryology, you can learn the pathological positions.
So the interventricular septal defect is caused by the defect in tracheinus
Yes.
and
Because
B1
as you
under.
remember, the lower part of the truncoconal septum take part in the formation of
Membranous.
When they don't grows, okay, as a result, the same time we have an interventricular septal.
I think that it's better if we talk this lecture before we talk in the lecture of the of the anatomy of the cardiovascular system.
Okay, the A1, do you know the meaning of transposition of the greater vessels? What's the reason of the formation of the transposition of the great vessels? Look at the pictures.
Isn't that when the position is slightly?
Look at the aorta.
So they changed place.
Why they change place?
Birth defect.
Why the aorta receive blood from the right side?
Because of the septum.
Because
Because the septum is in the trachis arteriosus.
can you explain more?
Because of the
because
different-
the septum before
Which
like
septum?
in the
Truncoconal.
truncus anterior.
Do you remember I told you when the septum is formed, they turn around each other.
Yeah.
Huh? If they don't turn, as a result, the aorta, ascending aorta, receive blood from the right side, the pulmonary receive from the left side. It's a vice versa the normal position. Is it clear? We say that transpositions, the change of the position of the ascending aorta and
When they wanted to repair they will not just repair that. They have to change the flow.
They all die before the birth.
Really?
Yes. This is severe malformations. The change of this not happening.
Well, because it's not.
You feel like a repair of the machine, huh?
No. What?
You can't-
I
You
also.
cannot change the engine of the BMW with the.
Doctor, I'm always thinking about solve.
No, it's not so. This is serious. Some of them is serious. The B1 is pulmonary valvular atresia. Okay, the pulmonary valve is not formed. Look at the pictures. We have a patent duct arteriosus. This one is aortic valvular stenosis, A1, and B1 atresia. One of them is narrowing A, one of them is not develops. And the aortic valve atresia, we have again valvular, patent duct arteriosus. Okay, that's all. Now we go to